we have electrical energy. See, what is electrical energy? Electrical energy is a work energy. It is a work energy which is used to transport a charge from one place to another in an electric circuit. This energy is used when electric current flows through the circuit. Okay, we will discuss about this. See, let us consider. I will just break down this diagram into the simplest concept. See what we have. We have a bulb. We'll take it as a resistance. It will be connected to a battery. It will be connected to a battery whose potential difference is V. This is R. This is V. Okay, what we have to derive, what we have to do, we have to derive the equation for electrical energy. Electrical energy, what is the meaning of energy? Yes, energy. See, work done to transport a charge, work done to transfer a charge. What is energy? Energy is nothing but your work done per unit time. What is work done per unit time? Work done per unit time is nothing but your power. And one more thing, what is the second definition for work done? Work done in terms of electrical physics, it will be V into Q over T. What is V? Voltage. What is Q? Charge. So our W, another formula is what? It is V into Q. Upon me what we have? Upon me we have T. So therefore we can say, see how it comes? It will come like we have V is equal to W upon Q. That means your W will be equal to what? It will be equal to V into Q. Okay, one more thing, if you discuss about the power further, what can be further? V into, how you will define charge? Yes, charge can be current into time. Why? Check the first definition. In the first definition we discussed about current was charge per unit time. Therefore charge can be current into time. Am I right? Yes. Current is charge per unit time. Charge will be current into time. That means what? In place of charge, I can write I into T. Upon me, what we have? Upon me, we have T. So T and T will get cancelled, and our power formula will be equal to what? It will be equal to V into I. So what you can do now? Now you have one more formula for power. The first formula for power was W is equal to, sorry, P is equal to W upon T. Second formula we have V into I. Can anyone give me the hint for the third formula? Anyone? Yes. See what we have. We have V is equal to I into R. Right? So therefore your power will be equal to, what is V? V is IR. And what we have? We have I. So I into I will be what? It will be I square R. And what I did, in place of V, I put this, I substituted this value. V is equal to IR. Multiplication may we have I. So it will be what? It will be I square into R. Anyone with the next formula? This will be your second formula. Sorry, third formula for power. Anyone else with more formulas? Anyone? See, in place of R, what you can write? In place of I, what you can write else? V is equal to IR. That means I is equal to V over R, right? So therefore your power will be equal to, what is current? Current is I square. So you can write here V square over R square into R. So R and R square will get cancelled, and you will get power formula as V square over R. Okay, so this is your third formula. This is your third formula, that is V square over R. Okay, once more with this derivation, see, this is the simplest derivation and can be asked in your exam for 3 marks. The first thing, what we studied, what is energy? Energy is nothing but work done per unit time. What is work done per unit time? The work done per unit time is power. Okay, we have one more formula for work done. What is work done? Work done is equal to V into Q. So in place of W, what you can write? You can write V into Q over T. Then after that we have power is equal to V into, what is Q? Q is I into T. over what we have over T. So T and T will get cancelled and you will get V into I. After that we can write from Ohm's law, it is V is equal to IR. So in place of V, I am substituting this value. So your power will be equal to what? Your power will be equal to I square R. I will become I square into R. And what else? In place of current, I can write V over R. So in place of I can write V square over R. So therefore, your power will be equal to V square over R square into R. So R square will get cancelled and you will get V square over R. So your second formula, this will be your first formula. Okay, then what will be the unit of power? Yes, the unit of power will be it will be in terms of watt. Unit will be watt. W-A-T-T, watt. Okay, then few more things about the power. See, in series, what will be power, and in parallel, what will be the power? See, in series, 1 upon P1, 1 upon P2 will be equal to P1 plus P2 over P1 into P2. So that means your power in series will be equal to P1 P2 over P1 plus P2. This is the case for series. What for parallel? For the case of parallel, it will be simple. In parallel, your power will be P1 plus P2. That's it. Okay. In series, it will be P1 into P2 over P1 plus P2. And in parallel, it will be PP is equal to P1 plus P2. Let's solve some numericals based on this. Yes. First question from this topic, electrical energy and power. The questions are: two electric bulb P and Q have resistance in ratio 1:2. They are connected in series across a battery. Find the ratio of power dissipation in these bulbs. I repeat the question. The question is: two electric bulb P and Q have the resistance of ratio 1:2. Let me highlight the given. Yes, the question in this question, resistance are in the ratio 1:2. They are connected in series. Find the ratio of power dissipation. Yes. Okay. Two bulb having resistance of ratio are 1:2. 1:2 means R1 upon R2 is what? It is 1 upon 2. It is connected in series. In series, what will be the things? In series, your current will be same. In series, your current will be same. And what you are supposed to find? You are supposed to find P1 to P2. See, we have formula. We have formula that P is equal to I square into R. As in series, current is same. Current in series, current will be same. So I will write in series, your current will be equal to I1 will be equal to I2. That means what? That means your P will be directly proportional to R. That means your P1 over P2 will be equal to R1 over R2. So this will be equal to, what is R1 over R2? 1 upon 2. So your ratio of the power will be what? Your ratio of the power will be equal to 1 upon 2. Okay, this will be our answer. Okay, once more, we'll see the concept. See what we have. We have the ratio of resistance. We are supposed to find the ratio of power. So your power ratio will be P1 over P2. That will be equal to what? That will be equal to R1 over R2. How we get that? We get that by this equation. We have P is equal to I square R. I will be constant because it is in series. Therefore, we'll say that P is directly proportional to R. So this will be the things. Okay, this question was asked in 2019 for 3 marks. 2019 for 3 marks. 2019, it was asked for 2019 for 3 marks. Now, let's solve the next question. The next question is the potential difference applied across a given resistor is altered so that heat produced per second increases by factor 9. By what factor does the applied potential difference changes? See, we will solve the first one. We'll solve the A1. See what is there in the A1. In the A1, it is that the potential difference across given resistor is altered so that heat produced per second increases by factor 9. By what factor applied voltage? By what factor applied potential difference changes? We have to find the new potential difference. If heat produced per second increased by 9, we have to find that. Okay, so see what is heat produced per second. Heat is nothing but your energy. Energy is nothing but your work done per second. Check. See, E over T. E over T is nothing but your W over T. W over T is nothing but your heat, and W over T is nothing but your power. That means what? That means you can say, see, and what is the formula for power? Power formula will be V square into, we have formula for power as V square over R. See, there is no change of resistance. That means resistance will be constant. So what you will write? You will write P is directly proportional to V square. Once more, see what is there in the question. I'll repeat the question. Just understand the things. In the first question, that is in this question, the thing is the potential difference is altered so that heat produced per second increases by factor. Heat is nothing but your energy. Per second means time. Energy per second time can also be written as work done per unit time. What is work done per unit time? Work done per unit time is nothing but your power. That means power is increasing by the factor of 9. Power is increasing. Power, or you can write it as H. And what is the formula for power? That is H. The formula is V square R. Now, if you check, you can write that your heat is directly proportional to V square. No, sorry, not V square R. Your formula for power will be equal to, the formula for power will be equal to V square over R. So therefore you will write that heat is directly proportional to V square. See, new is, what is the new one? New one is V dash. Potential difference per second increase by factor 9. That means what? Here in this case, new H is how much? It is 9 times previous H. New H is how much? It is 9 times the previous H. What we have to find? We have to find the new potential difference. I will name it as V dash. So this will be what? This will be H dash over H will be equal to V dash over V. It will be in square. So therefore, what in place of h dash? In place of h dash, you will write 9h over h is equal to, in place of v dash square, what will be there? We will write v dash square over, what in the place of v square? We will write only v. So h and h will get cancelled. So therefore, your v dash square will be equal to 9v square. That means your v dash will be equal to the root of 9v square. What is the root of 9v square? It will be 3v. So if heat factor is increasing by factor 9, if heat is increasing by factor 9, the potential difference will increase by factor 3. Okay, then what we have, then we have the next one, then we have the next question, that is, first I will erase the first one. Yes, in the next one, in the B, the question is, in the figure shown, emitter A and A resistor of 4 ohm are connected to the terminal of the source. The EMF of the source is 1 volt, having internal resistance 2 ohm, so it's 12 ohm, internal resistance of 2 ohm. Calculate voltmeter and ammeter reading. Calculate voltmeter and ammeter reading. It is for 3 marks from year 2015. I repeat the question. In this question, we have an ammeter of resistor 4 ohm are connected in the terminal of the source. The EMF of the source is 12 volt, having internal resistance of 2 ohm. Calculate voltmeter and ammeter reading. See what we have in this case. In this case, we have EMF. EMF is how much? EMF is, yes, 12 volt. After that, we have current. Yes, we have current. Current is how much? Current is 2 ampere. Current is 2 ampere. What else we have? We have this small r. What is small r? Small r is your 2 ohm. So what we are supposed to find? We are supposed to find the voltmeter and ammeter reading. Voltmeter reading means V we have to find. And we know the formula for V. V is what? It is E minus IR. What is E? 12 minus. What is I? 2. What is R? 2. 2 2s are 4. 12 minus 8 how much? Yes, 8 volt. Okay, so we have found the value of voltmeter. Now we are supposed to find the ammeter reading. What do you mean by ammeter? What do you mean by ammeter reading? Ammeter reading is nothing but your current. What is current? Yes, E net over R net. What is E net? Check. What is E net? Net EMF. Net EMF. See, what is net EMF? Net EMF is 12 volt. Net EMF is 12 volt. What is net resistance? If you check net resistance, it will be equal to this is your 4 ohm and we have internal resistance of 2 ohm, so it will be 4 plus 2. 4 plus 2 will be how much? It will be 6. What is R net? R net is net resistance, R plus R, big resistance and internal resistance. So this will be equal to what? This will be equal to 2 ampere. Okay, then yes. Now next question, it's a multiple choice question. Question number 3. The question is, identify the correct formula for electrical power. Time taken to electric work done per unit time taken, electric power is equal to work done into time taken, or D, electric power is equal to 1 upon electrical work done. Yes. Anyone? Akhil, my dear, I'm asking the formula for electrical power. What is the formula for electrical power? We have these 4 options. Yes, Akhil, I have zoomed the question. I hope it is visible to you now. What will be the answer? Identify the correct formula of electrical power. What will be the formula for power? So the correct answer is, what is the formula for power? Power is work done per unit time. So what is work done per unit time? Option B. So option B is the right answer. Okay.